What is the cluster autoscaler?
The cluster autoscaler automatically adjusts the number of nodes in a cluster to ensure pods have resources to run and nodes are not underutilized. It scales up when pending pods cannot be scheduled due to insufficient resources by adding nodes to a node group. It scales down when nodes are consistently underutilized and their pods can be rescheduled onto other nodes. The cluster autoscaler works with cloud providers' autoscaling groups and is commonly used alongside the HPI for full elasticity.
What is Carpenter?
Carpenter is an open-source, flexible Kubernetes node provisioner that automatically launches right-sized compute resources in response to unschedulable pods. Unlike the cluster autoscaler, which works with pre-configured node groups, Carpenter evaluates the aggregate resource requirements of pending pods and directly provisions optimally sized nodes from the cloud provider IPI. It can consolidate workloads onto fewer nodes and terminate idle nodes, reducing cost. Carpenter was originally built for AWS, but now supports other providers.
How do you view logs for a pod in Kubernetes?
You view pod logs with kubectl logs pod name. To see logs for a specific container in a multi-container pod, use the C container name flag. The F flag streams logs in real time. The previous flag shows logs from the previously terminated container, useful for debugging crash loops. The since and since-time flags filter logs by time. For production at scale, logs should be shipped to a centralized system like Elasticsearch, Loki, or Splunk using a log aggregation agent.
What is the metrics server in Kubernetes?
The metrics server is a cluster-wide aggregator of resource usage data. It collects CPU and memory metrics from the kubectl summary, IPI on each node, and exposes them through the Kubernetes metrics IPI. kubectl top node and kubectl top pod use the metrics server. The horizontal pod autoscaler also relies on it for CPU-based scaling. The metrics server is not a long-term storage solution. For historical metrics and dashboards, use Prometheus and Grafana.
How does Prometheus integrate with Kubernetes?
Prometheus is the de facto standard for Kubernetes monitoring. It scrapes metrics endpoints exposed by pods, nodes, and Kubernetes components. KubeState Metrics generates metrics about the state of Kubernetes objects like deployments and pods. Node Exporter collects host-level metrics. Prometheus uses service discovery to automatically find scrape targets in Kubernetes by reading pod and service annotations or using the Kubernetes IPI. Grafana is typically used for visualization.
What are liveness, readiness, and startup probes?
Liveness probes determine if a container is running properly. If the probe fails, the kubectl kills and restarts the container. Readiness probes determine if a container is ready to accept traffic. If it fails, the pod is removed from service endpoints, so no traffic is routed to it. Startup probes determine if an application has started. If configured, liveness and readiness probes are disabled until the startup probe succeeds, giving slow-starting applications time to initialize.
What types of health probe mechanisms does Kubernetes support?
Kubernetes supports 3 probe mechanisms. HTTP, get probes send an HTTP, get request to the container, and succeed if the response code is between 200 and 399. TCP socket probes check if a TCP connection can be established to the specified port. Exec probes run a command inside the container and succeed if the exit code is 0. Starting with Kubernetes 1.24, gRPC probes are also supported for checking gRPC services using the standard health checking protocol.
What is distributed tracing in the context of Kubernetes?
Distributed tracing tracks requests as they flow through microservices in a Kubernetes cluster, helping identify latency bottlenecks and understand dependencies. Each request gets a trace with spans representing operations in each service. Tools like Jaeger, Zipkin, or commercial solutions like Datadog, a PM collect and visualize traces. Service meshes like Istio can inject tracing headers automatically. Applications need to propagate tracing headers to participate in distributed traces.
What is a custom resource definition?
A custom resource definition allows you to extend the Kubernetes API with your own resource types. You define the schema of the new resource, and Kubernetes creates a new API endpoint for it. Users can then create, read, update, and delete instances of your custom resource using kubectl or the Kubernetes API just like built-in resources. CRDs are the foundation for building Kubernetes operators and extending Kubernetes with domain-specific abstractions.
What is a Kubernetes operator?
A Kubernetes operator is a method of packaging, deploying, and managing a Kubernetes application using custom resources and controllers. It encodes the operational knowledge of a human operator, like how to scale, backup, and recover a database, into software. An operator consists of a CRD defining the application's configuration schema and a controller that watches the CRD instances and takes actions to reconcile the actual state with the desired state. Popular operators include the Prometheus operator and various database operators.
What is the reconciliation loop in a Kubernetes controller?
The reconciliation loop is the core pattern of a Kubernetes controller. The controller watches for changes to resources, computes the difference between the current state and the desired state specified in the resource spec, and takes actions to eliminate that difference. If the reconciliation fails or external factors change the state, the loop runs again. This pattern makes controllers resilient and self-healing. The system continuously works toward the desired state regardless of external disruptions.
What is the controller runtime library?
Controller runtime is a Go library developed by the Kubernetes SIG architecture community that simplifies building Kubernetes controllers and operators. It provides abstractions for building reconcilers, managing caches of Kubernetes objects, setting up watches on resources, handling RBAC, and running health checks. KubeBuilder and Operator SDK both use controller runtime under the hood. It greatly reduces the boilerplate needed to write a production-quality controller.
What is KubeBuilder?
KubeBuilder is a framework for building Kubernetes APIs and controllers using Go and the controller runtime library. It scaffolds the project structure, CRD definitions, controller code, RBAC manifests, and integration tests. KubeBuilder uses code generation based on annotations to create boilerplate, allowing developers to focus on business logic. It is one of the two primary frameworks for building operators, alongside the Operator SDK.
What are finalizers in Kubernetes?
Finalizers are keys on a resource's metadata that tell Kubernetes that cleanup work must happen before the resource can be deleted. When you delete a resource with finalizers, Kubernetes sets a deletion timestamp but does not remove the resource. The responsible controller performs cleanup actions and then removes the finalizer from the resource. Once all finalizers are removed, Kubernetes garbage collects the resource. Finalizers ensure that external resources, like cloud volumes, are cleaned up before the Kubernetes object is deleted.
What is owner references in Kubernetes?
Owner references create a parent-child relationship between Kubernetes objects. When an owner object is deleted, Kubernetes automatically garbage collects all dependent objects that reference the owner via owner references. For example, when a replica set is deleted, it is listed as the owner of its pods, so the pods are deleted too. Deployments own replica sets, and replica sets own pods, creating a hierarchy. Owner references enable cascading deletion and help controllers identify resources they are responsible for.
What are Kubernetes API aggregation layers?
The API aggregation layer allows extending the Kubernetes API by writing and deploying custom API servers. Unlike CRDs, which add resources to the existing API server, aggregated API servers run as separate processes and handle requests for their API groups independently. The main API server proxies requests to them. This allows implementing custom business logic, different storage backends, or Kubernetes-style APIs for non-Kubernetes services. The metrics server uses API aggregation.
What is kubectl?
Kubectl is a tool that provides best practice ways to create a Kubernetes cluster. Kubectl init sets up a control plane node by configuring the API server, etcd, controller manager, and scheduler. Kubectl join adds worker nodes to the cluster. Kubectl upgrade manages cluster version upgrades. It does not provision underlying infrastructure. You still need to provision vmtks and install prerequisites. Kubectl follows Kubernetes best practices like generating certificate authorities and enabling RBAC by default.
How do you upgrade a Kubernetes cluster?
Upgrading a Kubernetes cluster typically follows a version-at-a-time approach. For kubectl clusters, you upgrade the control plane first using kubectl upgrade plan and kubectl upgrade apply. Then update the kubectl binary, kubectl, and kubectl on each node. Worker nodes should be drained with kubectl drain to safely evict workloads before upgrading the kubectl and rejoining. Cloud-managed clusters automate much of this process. You should always back up etcd before upgrading.
How do you drain a Kubernetes node?
Draining a node safely evicts all pods from it, so the node can be taken offline for maintenance. Kubectl drain node name marks the node as unschedulable with a taint and evicts all pods, respecting pod disruption budgets. Pods managed by controllers like deployments will be rescheduled on other nodes. You may need ignore daemon sets because daemon set pods cannot be rescheduled. After maintenance, use kubectl uncordon to re-enable scheduling on the node.
What is kubectl cordon and uncordon?
Kubectl cordon marks a node as unschedulable, preventing the scheduler from placing new pods on it, but existing pods continue running. This is the first step of node maintenance. Kubectl uncordon removes the unschedulable taint, re-enabling scheduling. Kubectl drain is more comprehensive than cordon because it also evicts existing pods. Cordon alone is useful when you want to stop new workloads from landing on a node temporarily without disrupting existing ones.
How do you back up etcd in Kubernetes?
You back up etcd using the kubectl snapshot save command, which creates a point-in-time snapshot of the entire etcd database. The snapshot should be stored securely, ideally offsite. You need to provide the CI certificate, client certificate, and client key to authenticate with etcd. Restoring from a backup uses kubectl snapshot restore and requires stopping the API server, restoring the data directory, and restarting etcd. Regular automated etcd backups are critical for cluster disaster recovery.
What is a kubeconfig file?
A kubeconfig file is a YAML file that stores cluster connection configuration, including cluster IP, iServer URL, certificate data for authentication, and context definitions. A context binds together a cluster, a user, and a namespace. Kubectl reads the kubeconfig from ~kube/config by default or from the path set in kubectl ONFIG. Multiple clusters and users can be stored in one file. kubectl config use context switches between configured contexts, allowing management of multiple clusters.
What is the difference between kubectl apply and kubectl create?
kubectl create is an imperative command that creates a new resource and fails if the resource already exists. kubectl apply is a declarative command that creates the resource if it does not exist or updates it if it does. kubectl apply uses server-side or client-side apply to track which fields were last applied, allowing it to identify and remove fields that are no longer present in the manifest. kubectl apply is preferred in GitOps and CI/CD workflows because it is idempotent.
What is kubectl exec?
kubectl exec runs a command in a container within a running pod, similar to Docker exec. For example, kubectl exec at pod name bash opens an interactive bash shell. The I flag keeps stdin open and T allocates a TTY. You specify the container with C if the pod has multiple containers. kubectl exec is invaluable for debugging. You can inspect file contents, run diagnostic commands, or test connectivity from inside the container's network namespace.
What is kubectl port forward?
kubectl port forward creates a tunnel between your local machine and a port on a pod or service in the cluster. For example, kubectl port forward pod/mypod 8080. 80 makes the pod's port 80 accessible at localhost 8080. This is useful for accessing internal services during development and debugging without exposing them externally. It is not suitable for production traffic as it is not highly available and terminates when the kubectl process stops.
How do you manage multiple Kubernetes clusters?
Multiple clusters are managed by configuring multiple contexts in the kubeconfig file. Each context references a cluster endpoint, user credentials, and a default namespace. kubectl config get contexts lists all contexts. kubectl config use context switches the active context, and kubectl config current context shows the active one. Tools like kubectl and kubins make switching contexts and namespaces faster. In CI/CD systems, kubeconfig is typically provided via environment variables or secrets.
What are resource quotas in Kubernetes?
Resource quota objects set hard limits on the total amount of resources that can be consumed in a namespace. They can limit compute resources like CPU and memory, object counts like the number of pods or services, and storage resources. When a quota is in place, creating or updating resources that exceed the quota limit will be rejected. Resource quotas help enforce fair resource sharing between teams using the same cluster.
What are limit ranges in Kubernetes?
A limit range policy constrains resource allocations for objects like pods and containers in a namespace. It can set default request and limit values for containers that do not specify their own, enforce minimum and maximum values for requests and limits, and limit the ratio between request and limit. Limit ranges ensure that every container has appropriate resource specifications, preventing unbounded resource consumption and making scheduling more predictable.
What is a node in Kubernetes, and what information does it expose?
A node is a Kubernetes object representing a worker machine. It exposes information through its status, including addresses with IP and hostname, conditions showing ready, disk pressure, memory pressure, and PID pressure states, capacity and allocatable resources for CPU and memory, node info with OS and kernel version, and the list of running pods. Node status is updated by the kubectl and monitored by the node controller, which marks nodes as unreachable if they stop sending heartbeats.
What is the purpose of the kube node lease namespace?
The kubenode lease namespace holds lease objects associated with each node. The kubectl sends heartbeat updates by renewing these lease objects, which is more efficient than updating the full node status object. The node controller uses lease renewal timestamps to detect node failures without requiring heavy reads of the entire node object. This reduces IPI server load in large clusters with many nodes. If a lease is not renewed within the lease duration, the node is considered unhealthy.
What is GitOps and how does it relate to Kubernetes?
GitOps is a practice where the entire desired state of a Kubernetes cluster is stored in a Git repository. A GitOps agent running in the cluster continuously synchronizes the cluster state with the Git repository, automatically applying changes when commits are pushed and alerting on drift. This makes deployments auditable, reproducible, and reversible through Git history. Argo CD and Flux are the two most popular GitOps tools for Kubernetes.
What is Argo CD?
Argo CD is a declarative GitOps continuous delivery tool for Kubernetes. It monitors Git repositories for changes to Kubernetes manifests and automatically synchronizes the cluster state to match. Argo CD provides a web UI and CLI for visualizing application state, manually triggering syncs, and rolling back deployments. It supports multiple application manifests formats including plain YAML, Helm charts, Customize, and JSON, and can manage deployments across multiple clusters.
What is Flux?
Flux is a GitOps tool for Kubernetes that synchronizes cluster resources with source repositories. It uses a set of Kubernetes controllers for different sources and reconcilers. Flux supports Git repositories, Helm repositories, and OCI registries as sources. It integrates with image automation to update manifests when new container images are pushed. Flux is a CNCF graduated project and is known for its composable, Kubernetes native architecture.
What is Customize?
Customize is a configuration management tool built into kubectl that allows customizing Kubernetes YAML without templates. It works through a customization YAML file that references base resources and overlays that patch or extend them. Unlike Helm, Customize does not use a separate templating language. It patches native YAML using strategic merge patches and JSON patches. It allows managing environment-specific differences like replica counts or image tags without forking the base manifests.
How do you troubleshoot a pod stuck in pending state?
A pod in pending state means the scheduler cannot place it on a node. You start with kubectl describe pod to see the events, which usually contain a clear reason. Common causes include insufficient CPU or memory on all nodes, a node selector or affinity rule that matches no nodes, a required persistent volume claim that cannot be bound, a taint on all nodes with no matching toleration, or namespace resource quotas being exceeded. Fixing the underlying resource constraint or scheduling rule resolves the issue.
How do you troubleshoot a pod in crash loop backoff state?
Crash loop backoff means a container is starting but repeatedly crashing. Kubectl logs pod name shows the current container logs, and kubectl logs pod name previous shows logs from the previous crashed instance. Kubectl describe pod shows the exit code and events. Common causes include application errors or bugs, missing environment variables or configuration, connection failures to dependencies like databases, resource limits too low causing OOM kills, incorrect command or entry point, and failed file permission checks.
What does the OOM killed status mean in Kubernetes?
OOM killed means the container was killed by the Linux out-of-memory killer because it exceeded its memory limit. You can confirm this by checking the pod's last state in kubectl describe pod, which will show the exit code 137 and the reason OOM killed. To fix it, increase the memory limit in the pod spec, optimize the application's memory usage, or investigate memory leaks. Setting resource limits too low is a common cause, but you should also verify the application is not leaking memory.
How do you debug networking issues in Kubernetes?
Network debugging starts with verifying the pod is running and has an IP. Kubectl exec into the pod and test connectivity with curl or wget to the target service. Verify the service exists and has endpoints with kubectl get endpoints. Check network policy rules that might be blocking traffic. Use DNS resolution testing to confirm service discovery works. Tools like NetShoot or kubectl sniff provide network debugging capabilities. Checking node and pod firewalls and security groups is also important in cloud environments.
What is kubectl describe, and when do you use it?
Kubectl describe provides a detailed, human-readable view of a Kubernetes resource, including its specification, current state, and most importantly, its events section. Events record important state changes, scheduling decisions, and errors from controllers. Kubectl describe is typically the first tool to use when troubleshooting, because the events section usually contains the direct reason for a problem like image pull back off, scheduling failures, or probe failures. It is more informative than kubectl get for diagnosis.
What causes an image pull back off error?
Image pull back off means Kubernetes cannot pull the container image. Common causes include the image name or tag being incorrect or not existing in the registry, the image being in a private registry without the proper image pull secret configured, network connectivity issues from the node to the registry, and registry rate limiting. Kubectl describe pod shows the error from the image pull attempt. Verify the image name and tag exist, check registry credentials, and confirm network connectivity from the cluster nodes.
How do you view events in a Kubernetes namespace?
Kubectl get events shows all events in the current namespace, sorted by time. Kubectl get events sort by equals. Last timestamp namespace equals my namespace shows events in a specific namespace, sorted by timestamp. Kubectl describe on a specific resource shows events related only to that resource. Events are short-lived, retained for about 1 hour by default. For longer-term event storage, tools like KubeEvents Exporter or a log aggregation setup can capture events to persistent storage.
What is the difference between pod logs and container logs?
In Kubernetes terminology, pod logs and container logs are often used interchangeably, but technically logs come from containers. When a pod has one container, kubectl logs pod name works. With multiple containers, you must specify the container with C. When a container restarts, the previous run's logs are accessible with previous, but only the most recent previous run is kept by the kubectl. For long-term log retention and searching across multiple pods, you need a centralized logging solution.
What tools help with Kubernetes troubleshooting and debugging?
Kubectl is the primary tool with describe, logs, exec, and event subcommands. K9s provides an interactive terminal UI for navigating cluster resources. Kubectl and Kubins make context and namespace switching fast. Stern tails logs from multiple pods matching a pattern simultaneously. Kubectl debug or ephemeral containers allow attaching a debug container to a running pod. Lens is a desktop application for visualizing cluster state. Network tools images like NetShoot provide networking utilities for in-cluster debugging.
What is eBPF, and how is it used in Kubernetes?
eBPF, Extended Berkeley Packet Filter, is a kernel technology that allows running sandboxed programs in the OS kernel without modifying kernel source code. In Kubernetes, eBPF is used by CNI plugins like Cilium to implement high-performance networking and network policies by processing packets at the kernel level, bypassing iptables. It is also used for observability, gathering detailed metrics and traces without sidecar overhead, and for security enforcement with tools like Falco and Tetragon.
What is a service mesh, and should you use one?
A service mesh adds a layer of infrastructure for service-to-service communication, typically using sidecar proxies to handle encryption, mutual TLS, traffic management, observability, and access control without application changes. Istio, Linkerd, and Console Connect are popular options. However, service meshes add significant operational complexity, latency from sidecar proxies, and resource overhead. You should use one only when you genuinely need features like mutual TLS between all services, advanced traffic splitting, or circuit breaking at the platform level.
What is Istio?
Istio is a popular open-source service mesh that provides traffic management, security, and observability for microservices. It injects an Envoy sidecar proxy into each pod, which intercepts all network traffic. Istio's control plane components include Istio-D, which manages configuration distribution, certificate issuance for mutual TLS, and service discovery. Istio enables features like intelligent load balancing, canary deployments, circuit breaking, automatic mutual TLS, and rich telemetry with minimal application changes.
What is multi-tenancy in Kubernetes?
Multi-tenancy in Kubernetes means multiple teams, applications, or customers share a single cluster. It is achieved through namespaces for resource isolation, RBAC for access control, network policies for network isolation, resource quotas for fair resource sharing, and limit ranges for per-pod limits. Harder isolation can be achieved with tools like vCluster for virtual clusters or with separate node pools. True multi-tenancy with untrusted workloads often requires separate clusters or VM-level isolation using Kata containers or gvisor.
What is a virtual cluster, vCluster?
vCluster creates virtual Kubernetes clusters inside a real Kubernetes cluster. Each virtual cluster has its own IP iServer, controller manager, and etcd running as pods in a namespace of the host cluster. Tenants interact with the virtual cluster IP iServer and see their own isolated view of resources, while workloads actually run on the host cluster's nodes through synchronization. vCluster provides stronger isolation than namespaces and is useful for development environments, CI/CD, and multi-tenancy use cases.
What is Kubernetes Federation?
Kubernetes Federation allows you to manage multiple Kubernetes clusters as a single entity. Federated resources are distributed to member clusters, and the federation control plane keeps them synchronized. Use cases include cross-region deployments for geographic distribution and high availability, and managing resources across development, staging, and production clusters from one place. kubectl is the reference implementation, though many organizations use tools like Argo CD application sets or Flux for multi-cluster management instead.
What is the Kubernetes Gateway IPI?
The Kubernetes Gateway IPI is a next-generation replacement for the Ingress IPI, offering more expressiveness, extensibility, and role-based separation. It introduces several resources. Gateway class defines the infrastructure provider. Gateway represents a load balancer instance with listeners. HTTP route, TCP route, gRPC route, and others define routing rules attached to gateways. The IPI separates concerns between infrastructure providers, cluster operators, and application developers, and supports advanced traffic patterns natively.
What is KubeVN?
KubeVN is a CNI plugin based on Open Virtual Network that provides enterprise-grade networking features for Kubernetes. It offers subnet management, network isolation, static IP assignment, VPC support, co-S policies, and hardware offloading. It is designed for scenarios requiring fine-grained network control, similar to traditional data center networking, and is popular in telecommunications and financial services sectors that need more network control than standard CNI plugins provide.
What is an ephemeral container in Kubernetes?
Ephemeral containers are temporary containers added to a running pod for debugging purposes. Unlike regular containers, they are not specified in the pod spec in advance. They are added to an existing pod on demand using kubectl debug. They share the pod's network and can optionally share a process namespace with the target container. Since distroless images have no shell or debugging tools, ephemeral containers allow attaching a debug image without restarting the application pod.
What is the Kubernetes resource model?
The Kubernetes resource model treats all managed entities, pods, services, deployments, namespaces, and more as resources accessible through the Kubernetes API. Every resource has an API version, a kind, metadata, a spec for desired state, and a status for observed state. Resources are organized by API groups and versions. Custom resources extend the model through CRDs. The API server provides CRUD operations on resources plus watch for real-time change notifications, which controllers use to implement reconciliation.
What is server-side apply in Kubernetes?
Server-side apply is a resource management strategy where the API server performs the field merge and conflict detection instead of kubectl. It tracks field ownership, recording which manager last set each field. When two managers try to set the same field, a conflict is reported. This prevents accidental overwrites in environments where multiple tools manage the same resource. It was introduced in Kubernetes 1.18 and is enabled with kubectl apply server-side.
What is the watch mechanism in Kubernetes?
The watch mechanism allows clients to receive real-time notifications when Kubernetes resources change. Instead of polling the API server, clients open a long-lived HTTP connection with the watch flag and receive a stream of events: IDDED, MODIFIED, DELETED as resources change. Controllers and operators use watches to react to changes immediately. The Kubernetes Informer pattern wraps the watch mechanism with a local cache to reduce API server load, only calling the handler when the cached state changes.
What are Kubernetes leases?
Kubernetes leases are lightweight objects in the Coordination Kubernetesio API group used for two purposes. Node heartbeats use leases in kubnode lease to efficiently report node liveness without updating the heavy node object. Leader election uses leases to coordinate which instance of a controller is active among multiple replicas. The leader continuously renews the lease, and other instances watch it, taking over if the lease expires. This pattern ensures only one instance acts while others remain on standby.
What is the Kubernetes IP discovery mechanism?
Kubernetes uses API discovery to allow clients to learn what resources and operations are available. The /API and /APIs endpoints return the list of API groups and versions. The /APIs/group/version endpoint returns available resources within a group. Kubectl API resources and kubectl API versions use this discovery mechanism. It is important for tools like kubectl, operators, and controllers that need to interact with different Kubernetes versions, where available APIs may differ.
What is containered?
Containerd is an industry-standard container runtime that manages the complete container lifecycle, including image transfer and storage, container execution, supervision, and storage management. It implements the container runtime interface that Kubernetes uses to interact with container runtimes, replacing the earlier direct integration with Docker. Containerd uses Runk to actually run containers according to the OCI specification. It is the default container runtime in most managed Kubernetes services and kubectl clusters.
What is the OCI specification?
The Open Container Initiative specification defines industry standards for container formats and runtimes. The OCI image specification defines how container images are structured and stored. The OCI runtime specification defines how to run a container from an image bundle. Runk is the reference implementation of the OCI runtime spec. These standards ensure interoperability between different container tools and runtimes, so an image built with Docker can be run by Containerd or any other OCI-compliant runtime.
What is gvisor?
gvisor is an application kernel written in Go that implements a substantial portion of the Linux system call Surface. It provides an additional layer of isolation between containerized applications and the host OS. Containers running inside gvisor use Runsk, an OCI-compatible runtime, instead of Runk. It intercepts system calls at the user space level, greatly reducing the host kernel attack surface. It is used in Kubernetes to provide stronger isolation for untrusted or multi-tenant workloads.
What is Kata containers?
Kata containers run containers inside lightweight virtual machines using hardware virtualization rather than Linux namespaces and cgroups. This provides VM-level isolation, making it much harder for a container escape to affect the host. Kata containers are OCI and CRI compatible, so they integrate transparently with Kubernetes using a runtime class to select the appropriate runtime. They are used for high-security, multi-tenant environments where namespace-based isolation is insufficient.
What is runtime class in Kubernetes?
Runtime class is a Kubernetes resource that allows selecting different container runtimes for pods. You define runtime classes that reference configured runtime handlers on nodes, for example, one for Runk standard, and another for gvisor or Kata containers, enhanced isolation. Pods specify which runtime class to use in their spec. This allows running different workloads with appropriate isolation levels in the same cluster without separate node pools.
What is KEDI?
KEDI, Kubernetes Event-Driven Autoscaling, is a Kubernetes operator that extends the horizontal pod autoscaler to scale applications based on external event sources beyond CPU and memory. Supported sources include message queues like Kafka, RabbitMQ, and a WSSQS, databases, HTTP request rates, and over 50 other scalars. KEDI can also scale to 0, completely removing pods when there is no work and restarting them when events arrive, which is not possible with the standard HPI.
What is Crossplane?
Crossplane is a CNCF project that extends Kubernetes to manage external cloud infrastructure resources using the Kubernetes IPI and GitOps workflows. You define cloud resources like RDS databases, S3 buckets, or VPC-TICS as Kubernetes custom resources, and Crossplane's providers reconcile those to the actual cloud resources. Teams can provision and manage cloud infrastructure through the same YAML manifests, GitOps tools, and RBAC used for application workloads, enabling a platform engineering approach to infrastructure management.
What is Tecton?
Tecton is a Kubernetes native CI/CD framework that defines pipelines as Kubernetes custom resources. Tasks represent individual steps. Pipelines chain tasks together. Pipeline runs execute a pipeline, and triggers start pipelines in response to events like Git pushes or pull requests. Tecton components run as regular Kubernetes pods, leveraging existing Kubernetes features for logging, secrets management, and scaling. Tecton Hub provides a community catalog of reusable tasks.
What are Kubernetes best practices for production deployments?
Production Kubernetes best practices include setting resource requests and limits for all containers, configuring liveness and readiness probes, using pod disruption budgets to protect availability, running multiple replicas with pod anti-affinity for high availability, using namespaces and RBAC for isolation, scanning container images for vulnerabilities, enabling network policies, encrypting secrets at rest, enabling audit logging, using a GitOps workflow for deployment management, and setting up monitoring and alerting with Prometheus and Grafana.
How do you manage secrets securely in Kubernetes?
Kubernetes secrets provide basic secret management, but are only base 64 encoded by default. For production, enable encryption at rest in etcd with a KMS provider like a WS-KMS or Azure Key Vault. Consider external secret management tools like HashiCorp Vault with the Vault Agent sidecar or External Secrets Operator, which syncs secrets from external stores into Kubernetes. Restrict access to secrets with RBAC. Avoid mounting secrets as environment variables when possible, since they are easier to leak, and regularly rotate secrets.
What is the External Secrets Operator?
The External Secrets Operator synchronizes secrets from external secret management systems, like a WS Secrets Manager, HashiCorp Vault, Azure Key Vault, and GCP Secret Manager, into Kubernetes secrets. You define an external secret resource that references the external secret path, and the operator fetches and creates or updates the Kubernetes secret. This keeps the actual secret values out of Git, while using external systems that provide auditing, rotation, and fine-grained access control.
How do you implement high availability for the Kubernetes control plane?
A highly available control plane requires at least 3 control plane nodes to form an etcd quorum that can tolerate one node failure. etcd should use an odd number of members, 3 or 5, to ensure quorum can be maintained. Multiple IP iServer instances run behind an internal load balancer. The scheduler and controller manager use leader election, so only one instance is active at a time. Worker nodes connect to the load balancer endpoint, not individual control plane nodes.
What is a multi-region Kubernetes strategy?
A multi-region Kubernetes strategy typically uses separate clusters per region rather than stretching a single cluster across regions, since cross-region latency degrades etcd performance. Each cluster runs its own control plane. A global load balancer like a WS Route 53 or Cloudflare distributes traffic across regional entry points. GitOps tools deploy consistent application configurations across clusters. Persistent data is managed with database replication or global databases. Cluster IPI or managed services like EKS can standardize cluster lifecycle management.
What is container image security best practice?
Container image security starts with using minimal base images like distroless or Alpine to reduce the attack surface. Never run containers as root. Set a non-root user in the Docker file. Scan images for vulnerabilities using tools like Trivy, Gripe, or Snike in C, I pipelines, and reject images with critical vulnerabilities. Keep base images updated and use specific tags or digest pins rather than latest. Use signed images with cosign for supply chain integrity verification, enforced by admission controllers like Kyverno or OP, a gatekeeper.
What is Kyverno?
Kyverno is a policy engine designed for Kubernetes that allows you to validate, mutate, and generate Kubernetes resource configurations using policies written in YAML rather than a special policy language. Policies can require labels, block privileged containers, inject sidecar containers, generate network policies when namespaces are created, and verify container image signatures. Kyverno runs as an admission controller and is a simpler alternative to OP, a gatekeeper, for many common use cases.
What is container image signing?
Container image signing uses cryptographic signatures to prove that an image came from a trusted source and has not been tampered with. Cosign, part of the Sigstore project, is the standard tool for signing OCI images. A signer generates a signature and attaches it to the image in the registry. Admission controllers like Kyverno or OP, a gatekeeper, can verify signatures before allowing images to run in the cluster. This is a key practice for software supply chain security.
What is the Kubernetes CIS benchmark?
The CIS Kubernetes benchmark is a set of best practice guidelines for securing Kubernetes environments, published by the Center for Internet Security. It covers control plane configuration including IP iServer flags, etcd settings, and scheduler security, worker node configuration including kubectl settings, and Kubernetes policies including RBAC, network policies, and pod security. Tools like Kubebench automate checking a cluster against the CIS benchmark and report which checks pass and fail.
What is Kubebench?
Kubebench is an open-source tool that checks whether Kubernetes is deployed according to the CIS Kubernetes benchmark security guidelines. It runs checks on control plane nodes and worker nodes, testing IP iServer flags, etcd configuration, kubectl settings, RBAC policies, and more. Kubebench can run as a Kubernetes job or standalone binary and produces a report of past, failed, and warning checks with remediation guidance. It is commonly used in security audits and compliance assessments.
What is Falco?
Falco is a cloud-native runtime security tool that detects unexpected behavior in containers and Kubernetes using kernel system call monitoring via eBPF or kernel modules. It compares system calls against a set of rules and generates alerts when suspicious activity is detected, such as a shell being spawned in a container, writing to sensitive directories, or unexpected network connections. Falco integrates with Kubernetes to enrich alerts with pod and namespace context and can send alerts to Slack, PagerDuty, or other systems.
What is the difference between requests and limits for CPU and memory?
CPU and memory have different behaviors when their limits are exceeded. CPU is a compressible resource. If a container exceeds its CPU limit, it is throttled and slowed down, but it keeps running. Memory is not compressible. If a container exceeds its memory limit, the OOM killer terminates the process immediately with an OOM kill. This makes memory limits more critical to set correctly. Setting CPU limits can sometimes hurt performance through excessive throttling, and some teams choose to only set CPU requests without limits.
What is node overcommitment in Kubernetes?
Node overcommitment occurs when the sum of resource requests for all pods scheduled on a node exceeds the node's physical capacity. Kubernetes allows overcommitment because requests represent guaranteed minimums, not actual usage. Pods with burstable and best effort, co-S classes, may use more than their requests if resources are available. However, when actual consumption exceeds capacity, the kubelet evicts lower priority pods to reclaim resources. Overcommitment improves utilization, but increases eviction risk under high load.
What is pod topology spread constraints, and why use it over anti-affinity?
Topology spread constraints provide a more precise and declarative way to spread pods across failure domains compared to anti-affinity rules. You specify the exact maximum skew allowed between any two topology domains, making spreading behavior deterministic and easier to reason about. Anti-affinity rules are often used to prevent co-location, but do not explicitly control how pods are distributed across many zones. Topology spread constraints also work correctly during scale-down, whereas anti-affinity rules may result in uneven distribution.
What are common Kubernetes anti-patterns to avoid?
Common Kubernetes anti-patterns include running as root or with privileged containers, not setting resource requests and limits, using the latest image tag, which makes deployments non-deterministic, hard-coding secrets in container images or YAML files, not configuring health probes so unhealthy pods receive traffic, putting everything in the default namespace, using kubectl apply in pipelines without proper state tracking, creating stateful sets where deployments would suffice, and not planning for horizontal scaling from the start.
What is the recommended way to handle configuration changes in Kubernetes?
The recommended approach is to store all configuration in config maps or secrets and mount them as volumes or inject as environment variables. For environment variables, a pod restart is required to pick up changes. For volume-mounted config maps, Kubernetes automatically updates the files within a few seconds of the config map changing, allowing applications that watch their config files to pick up changes without restarting. Using an immutable config map and updating the pod spec to reference a new version is the safest pattern for zero downtime configuration changes.
What is the CNCF?
The Cloud Native Computing Foundation is an open-source foundation that hosts and fosters cloud-native projects including Kubernetes, Prometheus, Envoy, Fluent, Jaeger, Helm, and many others. The CNCF maintains the cloud-native landscape, which maps the ecosystem of tools. Projects go through sandbox, incubating, and graduated stages based on maturity. The CNCF is part of the Linux Foundation and promotes vendor-neutral cloud-native computing.
What managed Kubernetes services exist from major cloud providers?
Major cloud providers offer managed Kubernetes services that handle control plane management, upgrades, and integration with their infrastructure. Amazon Elastic Kubernetes Service handles the control plane and integrates with AWS services. Google Kubernetes Engine is considered the most feature-complete and was the first managed Kubernetes offering. Azure Kubernetes Service offers tight Active Directory integration. DigitalOcean Kubernetes, Linode Kubernetes Engine, and others serve smaller-scale use cases. Managed services significantly reduce operational overhead.
What is EKS Fargate?
EKS Fargate is a serverless compute option for Amazon EKS that allows running pods without provisioning or managing EC2 nodes. AWS automatically allocates the right amount of compute for each pod in an isolated micro-VM. You define Fargate profiles that specify which pod namespaces and selectors run on Fargate. It eliminates node management, simplifies scaling, and improves security through strong pod isolation. However, it does not support daemon sets, privileged containers, or many node-level features.
What is GKE Autopilot?
GKE Autopilot is a mode of Google Kubernetes Engine that fully manages the Kubernetes cluster infrastructure. GKE automatically provisions, scales, and manages nodes based on pod scheduling requirements. Users pay per pod rather than per node, and Google is responsible for node security, patching, and availability. It enforces stronger security defaults, including no privileged pods and required resource limits. Autopilot is ideal for teams that want Kubernetes without node management overhead.
What is Azure IKS and its key features?
Azure Kubernetes Service is Microsoft's managed Kubernetes offering. Key features include Microsoft Entra ID integration for authentication, Azure Active Directory RBAC integration, automatic cluster upgrades, and node image upgrades. Azure Monitor integration for logs and metrics, Azure CNI, and Kubernetes as networking options, Azure Policy integration with OPA Gatekeeper, managed node pools with autoscaling, confidential computing nodes with IMDS-EVS-NP, and OIDC integration for workload identity, allowing pods to authenticate to Azure services without storing credentials.
What is Cluster IPI?
Cluster IPI is a Kubernetes subproject that applies the Kubernetes declarative IPI model to cluster lifecycle management. You define clusters and machine groups as Kubernetes custom resources, and Cluster IPI controllers provision and manage the actual infrastructure through provider-specific implementations. Providers exist for AWS, Azure, GCP, vSphere, and others. This allows teams to manage cluster lifecycle, creation, scaling, upgrades, deletion, using the same GitOps workflows and tools as application management.
What is the Kubernetes operator pattern?
The operator pattern is a method for extending Kubernetes to manage complex stateful applications using domain-specific knowledge encoded in a controller. An operator uses CRDs to define the application's configuration schema and a controller that watches those resources and reconciles the cluster state, handling deployment, scaling, backup, upgrade, and failure recovery according to operational runbooks translated into code. Operator Hub.io hosts a catalog of community and vendor operators for databases, message brokers, and more.
What is open cost, and how does it relate to Kubernetes cost management?
Open cost is an open source, vendor-neutral standard and tool for measuring and allocating cloud and Kubernetes infrastructure costs. It attributes costs to namespaces, deployments, pods, and labels by combining Kubernetes resource usage data with cloud provider pricing. This allows teams to see which applications and teams are driving costs, enabling chargebacks, showbacks, and optimization efforts. Open cost integrates with Prometheus and tools like Grafana and is a CNCF sandbox project.
What is Velero?
Velero is an open-source tool for backing up and restoring Kubernetes cluster resources and persistent volumes. It captures the state of cluster resources as Kubernetes YAML files and backs up persistent volume data using volume snapshots or Ristic/Copia for file-level backups. Velero is used for disaster recovery, migrating resources between clusters, and creating pre-upgrade checkpoints. It integrates with cloud provider storage services for backup destinations and supports scheduled backups.
What is the difference between Kubernetes and Docker Swarm?
Docker Swarm is Docker's simpler native clustering solution, while Kubernetes is a more comprehensive and complex container orchestration platform. Swarm is easier to set up and manage, making it suitable for smaller deployments. Kubernetes offers more powerful features including more flexible scheduling, richer networking with policies, better auto-scaling, a larger ecosystem, and stronger multi-tenancy support. Kubernetes has become the industry standard, while Docker Swarm sees limited adoption. Most new projects choose Kubernetes.
What is the difference between Kubernetes and Nomad?
HashiCorp Nomad is a workload orchestrator that supports containers, VMs, Java applications, and native binaries, not just containers like Kubernetes. Nomad is simpler to operate and has a smaller footprint. Kubernetes has a vastly larger ecosystem, more operators and integrations, and more native support for Kubernetes-specific patterns like operators and CRDs. Nomad integrates tightly with HashiCorp Vault and Consul. Some organizations run both, using Nomad for specialized workloads and Kubernetes for containerized services.
What is K3s?
K3s is a lightweight, CNCF-certified Kubernetes distribution designed for edge computing, EOT, and resource-constrained environments. It packages all Kubernetes components into a single binary under 100 MB, replaces etcd with SQLite or embedded etcd by default, and removes legacy features and cloud provider integrations. K3s can run on IRM architectures and minimal Linux systems. Despite its lightweight nature, it is fully Kubernetes IP compatible and suitable for production edge deployments.
What is Kind Kubernetes in Docker?
Kind Kubernetes in Docker is a tool for running local Kubernetes clusters using Docker containers as nodes. It was primarily designed for testing Kubernetes itself, but is widely used for local development and CI/CD pipelines. Kind creates multi-node clusters quickly inside Docker containers, allowing testing of multi-node scenarios on a laptop or in a CI environment without provisioning cloud resources. It supports the full Kubernetes API and can load locally built images directly.
What is Minikube?
Minikube is a tool that runs a single-node Kubernetes cluster locally for development and testing. It supports multiple hypervisors and Docker as the driver. Minikube provides add-ons for common components like Ingress, Metrics Server, and Dashboard. It is the traditional tool for local Kubernetes development, though alternatives like Kind, K3D, and Docker Desktop with Kubernetes have become popular. Minikube's cluster runs in a VM or container and provides a realistic Kubernetes environment on a laptop.
What is Helm vs Customize?
Helm uses a Go-based template language to generate Kubernetes manifests, with charts as the packaging unit containing templates and a values file. It has a release management system with history and rollback. Customize is template-free, using declarative patches and overlays to customize raw YAML. Helm is better for distributing reusable application packages where users customize via values. Customize is better for managing environment-specific variations of your own application manifests. Many teams use Helm for third-party apps and Customize for their own services.
What is GitOps and what are its benefits?
GitOps is an operational model using Git as the single source of truth for declarative infrastructure and application state. Changes are made through pull requests, providing an audit trail and approval workflow. An automated operator continuously syncs the cluster to match the Git repository, detecting and correcting drift. Benefits include full auditability of all changes, easy rollback by reverting a Git commit, consistent environments through identical manifests, faster recovery from disasters by reapplying Git state, and improved developer experience by using familiar Git workflows for deployments.
What is progressive delivery in Kubernetes?
Progressive delivery is an approach to deploying software in controlled increments, gradually shifting traffic to new versions while monitoring for errors. In Kubernetes, this includes canary deployments that send a small percentage of traffic to a new version, blue-green deployments that switch traffic between two identical environments, and feature flags that toggle features for specific user segments. Tools like Argo rollouts and Flagger automate progressive delivery workflows with automatic promotion or rollback based on metrics.
What is Argo rollouts?
Argo rollouts is a Kubernetes controller that provides advanced deployment strategies, including canary and blue-green deployments with fine-grained traffic control. It integrates with ingress controllers and service meshes to shift traffic percentages between versions. It supports automatic analysis of metrics from Prometheus, Datadog, or other sources to determine whether to promote or roll back a release. Argo rollouts replaces the Kubernetes deployment for workloads requiring sophisticated deployment workflows.
What is Flagger?
Flagger is a progressive delivery operator for Kubernetes that automates canary deployments and a /b testing. It uses a canary custom resource to define the analysis metrics, thresholds, and traffic routing. Flagger integrates with service meshes like Istio and Linkerd, and ingress controllers like Nginx and Traefik for traffic shifting. It automatically promotes a deployment to 100% traffic if metrics are healthy, or rolls back if they degrade, making canary releases safe and automated.
What is the CNCF cloud-native landscape?
The CNCF cloud-native landscape is an interactive map of the cloud-native ecosystem maintained at Landscape CNCF-EO. It organizes hundreds of open-source and commercial tools into categories including provisioning, runtime, orchestration, networking, storage, streaming, observability, CI/CD, and app definition. It helps practitioners discover tools for specific needs and understand how different projects relate to each other. The landscape highlights CNCF-hosted projects versus commercial and other open-source solutions.
What is Service Level Objective (SLO), and how does it relate to Kubernetes?
A service level objective is a target value for a service reliability metric, such as 99.9% availability or 200 ms response time for the 95th percentile. In Kubernetes, SLOs guide decisions about replica counts, pod disruption budgets, resource allocation, and autoscaling configuration. Tools like Sloth and OpenSLO help define SLOs as code, with Prometheus recording rules and Grafana dashboards. SLOs connect operational decisions to business requirements, helping teams prioritize reliability work.
What is chaos engineering in the context of Kubernetes?
Chaos engineering involves deliberately injecting failures into a Kubernetes environment to validate resilience and identify weaknesses before they cause real outages. Tools like Chaos Monkey for Kubernetes, Chaos Mesh, and Litmus Chaos can terminate random pods, introduce network latency, kill nodes, drain persistent volumes, and more. Running controlled chaos experiments verifies that your Kubernetes workloads handle failures gracefully. Pods restart, traffic reroutes, and alerts fire as expected.
What is the Kubernetes Conformance Test Suite?
The Kubernetes Conformance Test Suite is a set of tests that verify a Kubernetes cluster correctly implements the Kubernetes API as specified. Any Kubernetes distribution claiming conformance must pass these tests. The CNCF certifies conformance for distributions through its Certified Kubernetes program. Conformance ensures portability. Applications running on a conformant cluster should work on any other conformant cluster. Tools like Sonaboy run the conformance test suite against any cluster.
What is Sonaboy?
Sonaboy is a diagnostic tool that runs in a Kubernetes cluster to gather information and run conformance tests. It can execute the Kubernetes conformance test suite to verify a cluster meets specifications. It also collects system information, logs, and status from nodes and cluster components into a tarball for analysis. It is used in CNCF certification testing, cluster health audits, and pre-upgrade validations. Sonaboy runs as pods in the cluster, making it deployable on any Kubernetes cluster.
What is cluster federation versus multi-cluster management?
Cluster federation actively synchronizes resources across multiple Kubernetes clusters through a federation control plane, keeping resources like deployments and config maps consistent across clusters. Multi-cluster management is a broader term for tools that operate across multiple clusters without necessarily synchronizing resources, such as deploying different workloads to different clusters, aggregating metrics from multiple clusters, or managing cluster lifecycle. Argo CD application sets, Flux with multi-cluster support, and Rancher are popular multi-cluster management approaches.
What is the difference between horizontal scaling and vertical scaling in Kubernetes?
Horizontal scaling increases the number of pod replicas, distributing load across more instances. It is handled by the horizontal pod autoscaler, which adds or removes pods based on metrics. It works well for stateless applications and provides better fault tolerance. Vertical scaling increases the CPU and memory resources allocated to existing pods, handled by the vertical pod autoscaler. It is more appropriate for stateful applications or those that cannot scale horizontally. Both can be used together, though they interact carefully to avoid conflicts.
What are the networking requirements for Kubernetes?
Kubernetes requires that all pods can communicate with all other pods across nodes without NIT. Nodes must be able to communicate with all pods. Pods see the same IP addresses that other entities see when communicating with them. This flat networking model is implemented by CNI plugins using overlay networks, VXLIN, Genev. Underlay routing, BGP, or cloud-native VPC routing. Each pod gets a unique IP from the pod CIDR. Services get IP tickets from a separate service CIDR managed by kubeproxy.
How do you implement blue-green deployments in Kubernetes?
Blue-green deployment in Kubernetes maintains two identical environments, blue, current, and green, new. You deploy the new version to green while blue serves production traffic. After validating green, you switch the service selector from blue pods to green pods, instantly redirecting all traffic. If issues arise, you switch the selector back to blue for an instant rollback. This requires double the resources during the transition, but eliminates downtime and allows instant, clean rollbacks compared to rolling updates.
What is canary deployment in Kubernetes?
A canary deployment releases a new version to a small subset of users or traffic, while keeping the old version running for the majority. In Kubernetes, a basic canary can be implemented by running a small number of new version pods alongside old version pods behind the same service, using the ratio of pod counts to control the traffic split. More sophisticated canary with precise traffic percentages uses ingress controllers, service meshes like Istio with virtual services, or dedicated tools like Argo rollouts.
What is pod preemption in Kubernetes?
Pod preemption allows the scheduler to evict lower priority pods to make room for higher priority pods that cannot be scheduled due to insufficient resources. When a high priority pod is pending, the scheduler searches for nodes where evicting lower priority pods would free enough resources. It then evicts those pods and schedules the high priority pod. Pod disruption budgets are respected during preemption. Preemption ensures critical system and application pods always have access to resources.
What is the garbage collection mechanism in Kubernetes?
Kubernetes garbage collection automatically deletes orphaned and unused objects. Owner references create parent-child relationships, and when an owner is deleted, dependents are collected either in foreground deletion, owner is held until dependents are deleted, or background deletion, dependents are deleted asynchronously. The kubectl garbage collects unused container images and dead containers on nodes. The IP iServer garbage collects terminated pods and completed jobs based on configured retention limits.
What is a projected volume in Kubernetes?
A projected volume maps several existing volume sources into a single directory in a pod. It allows combining a service account token, a config map, a secret, and a downward IP volume into one mount point. This is useful when applications expect multiple configuration sources in one location. The service account token in a projected volume uses a time-limited, audience-bound token from the token request IPI, which is more secure than the long-lived tokens previously mounted by Kubernetes.
What is the downward IPI in Kubernetes?
The downward IPI allows pods to consume information about themselves without calling the Kubernetes IPI server. It exposes pod metadata like the pod name, namespace, labels, and annotations, as well as resource information like CPU and memory limits, as environment variables or files mounted from a downward API volume. This is useful for applications that need to identify themselves in logs or metrics with their pod name or inject their resource limits into the application configuration.
What is a Kubernetes admission webhook lifecycle?
When an IPI request arrives, the IPI server first authenticates and authorizes it, then runs built-in admission controllers. Next, mutating admission webhooks are called in parallel, then re-evaluated to apply any mutations. After mutation, validating admission webhooks are called to accept or reject the final object. If all checks pass, the object is written to etcd. Webhook timeouts and failures must be handled carefully. Fail open allows requests if the webhook is unavailable, while fail closed rejects them, which can block the cluster if the webhook is down.
What is the Kubernetes IPI versioning strategy?
Kubernetes uses IPI versioning to manage changes to IPI resources over time. Alpha IPIs, v1 alpha 1, may be removed or changed without notice. Beta IPIs, v1 beta 1, are reasonably stable but may still change. Stable or GIIPIs, v1, are stable and will not change in incompatible ways. Each IPI group maintains multiple versions, allowing gradual migration. Kubectl and tools must handle multiple IPI versions using conversion webhooks. Deprecated IPIs are removed after a defined deprecation period, announced in release notes.